Hello and welcome to this Azure Back to School session. My name is Alan Canan and my session today is on Azure Chaos Studio. Just a little bit of information about me. My name is Alan Canan. I'm a Microsoft Azure MVP and a Microsoft Certified Trainer, and I'm based out of Dublin, Ireland. You'll see my contact details on screen. Please check out my blog site and feel free to reach out to me on LinkedIn or Twitter if you want to connect. And if you have any questions about this session, please do feel free to reach out. I'd be delighted to answer them. And now on with my session. Okay, so first of all, what is chaos engineering? There's a few different definitions for this, but the one I've come up with is it's the practice of introducing deliberate faults in order to cause system component failures for the purposes of testing resilience and availability. Chaos engineering was born out of Netflix's migration to the cloud just over 10 years ago now, where they needed to create some tools for themselves to actually simulate what would happen when various components failed. How would the system respond? How resilient was the system? And how could they make it more highly available? So the whole purpose of this really is to identify those what ifs, as in what happens if this fails? What do we do if this component breaks? How do we mitigate against those outages and keep our systems online? We want to obviously improve our system resilience to those failures and outages, make our systems more highly available so that they stay online. And it's all about, of course, immunizing your systems and your applications against these failures, so that if a failure does occur, that you are immune and that you can keep running. And obviously by reducing downtime as well. If you do have an outage, it's about recovering as quickly as possible. So when should chaos engineering be applied? The answer to this is continuously. There's no right or wrong time to do this. You should really do this throughout your development lifecycle. There's two lines of thought here. There's shift left and shift right. So shifting left is at the design phase. Design is obviously key to any service or application that you might be deploying. So you want to make sure that you're testing right at the very start here. As you may know, with Azure, getting increased resilience and increased high availability can often require architectural redesigns. So you may need to redeploy some components. So it is very important to identify these issues early on. So testing early in the development lifecycle is very important. Design changes always require retesting. So every time you make a design change to your application or to your system, you do want to retest again. So it is very important to test right at the very start. Shift right then is to make sure that you test right through the pre-production and into production phases. So load testing will be a common example here. So you've designed your solution and you have it deployed, but can it actually handle that customer load that you expect, or even a customer load that you don't expect? You may anticipate a certain amount of users coming onto your website, for example, every day. What happens if that gets exceeded by 5x or 10x? Can your system handle that? You might want to test for that and just see, will it fall over or will it stay online? Of course, any new code deployments that you might push out also need to be tested again. You want to make sure there's no breaking changes there, and you want to minimize the blast radius if there is a failure. So if a component does fail, you want to minimize the disruption that causes, and that again can be an important part of your design process. So let's talk about Azure Chaos Studio. So this is a managed experimentation platform that Microsoft developed in the Azure portal. It's there to remove or reduce the need for manual or third-party experimentation. So you may have third-party tools that you use for this kind of thing already, or possibly you're doing a lot of this work manually. The whole purpose of Azure Chaos Studio is to take that manual effort away and create these experiments and then run them as you need to. It's designed to test your services and applications' response to those failures that you introduce. So you are deliberately injecting these failures into your system or into your application to see how it responds. None of your code will be modified. So if you have an application, it does not touch the application code. So you're not going to lose anything. Nothing will be affected there. The actual experiments for Azure Chaos Studio are defined either directly in the Azure portal, or you can define them as ARM templates and deploy them that way. You can also trigger these experiments by using logic apps. So yes, you can trigger them manually in the Azure portal, but if you want them to be triggered by an event or by a schedule, you can use a logic app to initiate the experiment as well. And those experiments are assigned permissions using managed identities. So you'll use a managed identity on the Azure resources that you're testing, and you can give that just as much permissions as the experiment needs to run. Just one thing to note, Azure Chaos Studio is still in public preview at the time of this recording. So just to give a quick overview before we start the demo, here's my demo environment. It's quite straightforward. I just have two virtual machines acting as web servers, so web server 1 and web server 2. And these are a load balanced pair of web servers, so sitting behind a public facing Azure load balancer. So that's my public endpoint for the tests here, and we will have a look and see what we can do with Azure Chaos Studio now. Okay, so here we are in the Azure portal now. As you can see, Azure Chaos Studio is still marked as in preview at the time of recording. So there are only a few options there right now, but they are planning to add more features to this over time. If I just click on targets here, first of all, you'll see a list of available targets that are currently supported by Chaos Studio. So right now these include virtual machine scale sets, network security groups, key vaults, Azure Kubernetes, and Cosmos DB. We're going to focus on doing some experiments with virtual machines for today. So if I just select a virtual machine, you have to enable this for experimentation, and you'll see you have two options for virtual machines. You can enable service direct targets. This simply allows Azure Chaos Studio to shut down that virtual machine. However, if you choose the agent-based target, again, this is just for virtual machines and virtual machine scale sets, this will give you more options. So this will allow you to do even further experimentation. For this, you will need a managed identity. So that managed identity is what has permissions to run those experiments. Optionally, you can deploy an application insights account. This is used for your diagnostics. So you'll need to select an existing applications insights account, and it will automatically pick up your instrumentation key. So I've already set this up for web server 1. Let me just onboard web server 2. First of all, we'll choose the enable service direct targets. This simply allows Azure Chaos Studio to be able to shut down the virtual machine. So you can schedule what happens if you stop the virtual machine. That's all that service direct can do for virtual machines. We'll just wait for that to deploy. Okay, web server 2 is enabled now for service direct. Now we'll just enable the agent base. So this actually installs an agent on the virtual machine, and that will allow you to do further experimentation. So I actually have a managed identity created already for this. You will have to create that in advance. And secondly, you will have to link this to an existing applications insights account, which again, I have prepared already. It will pick up the instrumentation key automatically. So let's just enable this and wait for that to complete. Okay, so my targets are ready now. Web server 1 and 2 are both enabled. Let's go over to experiments. So these are where you define your experiments in Azure Chaos Studio. As you can see, I've got a few prepared already, which we'll look at in a moment. But just to create the experiment, you simply click the Create button. You need to define where your target is for your experiment. So you have to select your subscription, resource group, and the location for your experiment resource. And then within the experiment designer, this is where you can specify multiple steps, different branches, delays, all that sort of stuff. I'll just have a quick look under the action section just to show you what's available today. Now this list will grow over time, but right now here is the current list of faults that you can add. So the first two listed here, VM shutdown and VMSS shutdown, are just the service-based experiments for virtual machines and virtual machine scale sets. For other VM-based ones like CPU pressure, physical memory pressure, disk pressure, these would require that agent to be installed. And as you can see, there is support for some other servers as well. So there's some AKS experiments you can implement. Azure Key Vault, access denials, what happens if you block access to Azure Key Vault. And there's some network-based ones as well, such as latency or network disconnections or even a DNS lookup failure. As I said, more services should be added to this over time, but for now, this is what you've got to work with. Let's just go back to my existing experiments. So I have an experiment in place to simulate what happens if the web servers are shut down. So I'll just click the edit button here to have a quick look at what we've done here. So I have 3 separate steps here. So these run in sequence. Step 1 shuts down web server 1. So remember, I've got 2 virtual machines here behind a load balancer. So I'm going to shut down web server 1 for 5 minutes. When the 5 minutes completes, it will actually shut down web server 2. One thing that's important to note here is after the experiment completes, it will actually start up that virtual machine again. So it does not leave it in a shutdown state. It will actually start it up again. So after those 5 minutes have elapsed, it will actually restart web server 1 and then move on to step 2, which is to stop web server 2 for, again, 5 minutes. And after that 5 minutes has elapsed, web server 2 will be started again. And then we're on to step 3, where it will shut down both web servers. So as you can see here, you can select your targets. And in this particular step, I've set shut down for 5 minutes, but I've selected both targets, both web server 1 and web server 2. So then we'll see what happens if both web servers go down. So in my demo environment, I've only got 2 web servers. So if they're both stopped at the same time, I should expect not to be able to access my website. Just to give a quick look at my load balancing setup. So I've got a single backend pool with those 2 web servers in place. And I have a public IP address in front of that. So if I browse to my public IP address of the load balancer, right now I'm getting connected to web server 1. Just for clarity, this is the public IP address directly on web server 1, and this is the public IP address directly on web server 2. So right now I'm being directed to web server 1. So let's run that experiment and see what happens. So let's just have another look at that experiment. So it's called web server shutdowns. And I mentioned permissions before. For the server space permissions for virtual machines, because it's a VM stop operation, you will need to apply the virtual machine contributor role. Okay, so you can see it gets created as a web server shutdown application that needs to be given the virtual machine contributor role, and that will be there for both web server 1 and web server 2. For other experiments, which we will come to a bit later on, they will need lesser permissions. So let's run this first experiment now, the web server shutdowns one, and see what happens. So I can click on the start experiment button. Just warns you that you may experience outages if you've configured your experiment to do so. That's exactly what I have. So if you are using this in production, bear in mind, of course, if you are simulating a fault, you may experience some downtime. Okay, so you can see that's running now. We can click on details and get further information. So it's actually going through step 1 now, which, as you may recall, shuts down web server 1. So that's running right now. If we have a quick look at web server 1, let's see if it's still running. Okay, that's actually stopped at this point. So what happens now if I go to my load balancer IP address? If you recall, I was being directed to web server 1. If things are working correctly, they should now send me to web server 2 because that VM has stopped. So the health probe of the Azure load balancer should have kicked in now and removes web server 1 from the backend pool. So I should now get redirected to web server 2 if I refresh this. And yes, it's working. So I am being sent to web server 2 because that is still online at this time. So that's quite a simple experiment just to see, is my failover working? And if we give that the 5 minutes, what we should see is web server 2 will be stopped, and then I should be sent back to web server 1. So let's just wait for the next step of this experiment to kick in. Okay, we can see now that step 1 of my experiment has completed. So web server 1 shutdown test has completed, and we're now shutting down web server 2. As I mentioned before, we go back to web server 1, it should have restarted this machine for me. So yes, web server 1 is now running again. Web server 2 is now stopped. And if I go back to my load balancer public IP address, I should now be directed back to web server 1. which I am, which is great. So that's working as expected. My load balancer is doing its job and is removing a stopped web server from the backend pool as expected. Just to show you, I have an availability test set up continuously, actually from the same application Insights account that I was using for Chaos Studio. And this quite simply just shows a continuous probe on both the individual web servers' IP addresses and on the public IP address of the Azure Load Balancer. This is just there for demonstration purposes to show you the availability of the public endpoint of those web servers. So let's wait now another few minutes for step 2 to complete, and then we'll see what happens when both web server 1 and web server 2 are stopped at the same time. Okay, so we're into step 3 now. So both web servers have been stopped as part of this step. And if we take a quick look at the availability monitor, yes, we can now see that all 3 public endpoints are showing as unavailable. And it should come as no surprise then if I refresh my web page again, this should time out because both web server 1 and web server 2 are now offline. So this will simply time out. Okay, so a very basic experiment to start with, just literally shutting down some virtual machines to simulate what happens, but still a nice way to simulate what happens in the event of VM stoppages. But let's see if we can do something a little bit more granular now with another experiment. So let's take a look at one of the agent-based experiments now and see what happens if a service is stopped on one of our web servers. So I have one I've prepared earlier. If we just edit this, take a quick look and see what this does. So this is going to stop the W3 SVC service, which is the IIS service, basically the web server service on one of my web servers. So I'll just edit that. You can see I've chosen the option to stop the service for 10 minutes, and then I've just specified the name of that service. So you just have to specify the actual service name there. And the target resource for this one is going to be web server 1. So I'm going to leave web server 2 alone and just stop the service on web server 1 and see what happens. So remember, this is an agent-based service. This requires that VM extension to be installed on the server. And if we just go to web server 1 for a moment and just check the permissions on this. So let's just take a look at those role assignments required for the agent-based experiments. So just on my web server 1 role assignments, this experiment needs a reader level permissions. So the agent-based virtual machine experiments generally just need reader access in order to perform those experiments. So that's been added already. So those permissions are in place. My experiment is good to go. So let's go back to our experiment now. So we have everything set up. It's going to stop that W3 SVC service. So we're all in place to go. Just before we start, let's just check our load balancer IP address again and make sure we're back in business. Okay, we're connected to web server 1 once again. Let's just open up our Windows Admin Center here. And I'm just going to use this to monitor the services, just to show you that it's doing what we expect it to do. So under services, we should be able to find our W3 SVC service. And as you can see, that is running currently. So we're ready to go, I think. Let's start that experiment. So it just takes a moment for the agent to kick in and actually stop that service. Okay, so that service should be stopping momentarily. Let's just check web server 1's public IP address, and that has stopped. Maybe check our load balancer IP address. There we go. It's failed over to web server 2. And we'll just check this again. And you can see W3 SVC service has indeed stopped. So again, another simple experiment just to simulate what would happen. Not if the VM itself stops, but if the actual underlying web server service stops. Again, in this case, the Azure Load Balancer does its job, removes that web server from the backend pool and diverts all the traffic to the other healthy backend hosts. Let's go and do another experiment now. Okay, so I have another test here that I've created, and this again uses the virtual machine agent. And this time I want to do a stress test on the web server. So I'm going to do a CPU pressure test. So if we take a look here, what we're going to do here is bump up the CPU usage up to 99%, which is the maximum level you can set. And we'll do that for 10 minutes. We'll just do this on web server 1 and just test what happens if we target a single web server, bump up the CPU to 99%. How does it affect the responsiveness of that web server? Okay, so just web server 1 here. Before we start, I'm going to use a kind of a benchmarking tool here, and I'm just going to put in the public IP address that's directly on that web server 1 and just get a benchmark report from it. So I'm just using a third-party tool for this, and this will give me a report on that web server, and then we have something to compare to. Okay, so it's looking good. A+ rating, server speed 128 milliseconds, all looking okay there. But let's put some stress on that now. So what we're going to do is, first of all, we'll kick off that experiment. So let's start running that now. Again, that'll take a minute or two to kick in. Let's have another look at our Windows Admin Center. And we just have a look at the CPU load from here. So just in the overview tool, we should be able to monitor the CPU load here. Let's see. Check our experiment status. Okay, so that is now running. So the CPU pressure should go up to 99% pretty quickly. Let's have another look. And yes, we can see that's kicked in now. So the CPU is up to around 99% usage. Let's add a little bit more stress in this, and I'm actually going to use another Azure service that's also in public preview at the time of recording, and that's Azure Load Tester. So I have a test here. I'm going to actually create a new one. And I'm going to put in the IP address of web server 1. I'm going to simulate what happens if 500 virtual users connect in for 2 minutes at once. So not only am I stressing the CPU load on the machine, I'm also simulating what happens when all these virtual users connect in at the same time. So that should put a significant amount of pressure on that virtual machine. Now, my web server is pretty simple. It doesn't really do much other than display a hello world page. So I would still expect it to perform reasonably okay, but let's just simulate what would happen here. Okay, so our load test has started now. We've got those virtual users accessing the web server. We've got our CPU more or less maxed out. Let's test this again. Let's see what the result is now. So as you can see, my performance has dropped quite significantly now. I'm only getting a B rating, and my response time is much poorer, as you would expect when a server is being stressed both by a CPU load and by a number of users accessing together. So that's another example of how you could use Azure Chaos Studio to simulate what would happen if your, in this case, web server was under a significant amount of stress. So let's set up a brand new experiment from scratch here, just to go through the whole process from start to finish. And what I'm going to do this time is I'm going to create a network security group rule that will actually deny traffic. So just to simulate what would happen if an administrator came in and made a change to the network security group rules and how that might affect your web servers. So I do actually have a network security group in place protecting my web servers, but I have not yet onboarded it as a target for my experiments. So let's just do that first of all. So it's going to be a network security group, and let's just add a filter here to find it. Okay, great, I have two. I've one for web server 1 and web server 2, so let's do both of those. Enable those targets. Okay, so those targets are enabled. Now I can create my experiment. I need to specify where I want this experiment resource to be created. I'll call this NSG rule insertion. Let's add the fault. So there's a fault called NSG security rule. So I'll put this rule in place for 10 minutes. Which is enough time for me to test. It's an inbound rule. And my web servers are not very secure. They're not even running over HTTPS, just for testing. So I'm just running it over HTTP on port 80. So I want to see what happens if I block port 80. So I'm going to deny inbound traffic to port 80. I'll just give this a rule, block HTTP traffic. And then I need to specify my targets. So there's my two NSGs, which I want to add. And just give this a proper name. As you can see, it's going to prompt you to apply permissions. So let's just deploy that experiment. That's done. Now, permissions. Okay, so just to show you, I have my two network security groups, web server 1 NSG, which just has the allow all for HTTP, and the same for web server 2, allow all. We will need to add our permissions for the experiment we just created to the network security group resource. So let's go to access control. And for this particular experiment, because it's going to create a network security group rule, we need to add the network contributor permission. We're going to select our experiment from Chaos Experiments, it's NSG rule insertion. Assign that and do the same for NSG2. Okay, so permissions are in place. Let's just do a quick check, make sure we can access the web servers. That's all working fine, as expected. Now, if we run our experiment, that should insert that rule for us. And again, that's only a temporary rule for while this experiment is running. Once the experiment ends, it will delete that rule again afterwards. So once this rule gets inserted, it's going to be inserted with a priority of 100 as I specified. That will be a higher priority than my allow all rule, therefore it should block HTTP access, which should deny me access to my web servers. Okay, so that's running now. Let's see if it's inserted that rule yet. you can see, it has created that rule above my allow all, and it should be there for NSG2 also, which it is. So now both web servers are being denied access. So if I go to refresh this, I should get a timeout. There you go, the site cannot be reached. It's because my traffic is being blocked as expected. Okay, so once your experiment has completed fully, it should automatically delete that NSG rule. So maybe just check your NSGs, make sure the rules have been deleted. So that one's gone. And if I just refresh this in the portal, it should disappear. There we go. So you can see the NSG rule that was inserted by the experiment has now been deleted again afterwards. And that concludes the demo. So just finally, I'd like to end with saying a big thank you to Dwayne Atwick for organising the Azure Back to School event once again this year. I think it's my second time taking part. Really great event. I learn lots from it every year. I hope you enjoyed my session. Hope you got an insight into Azure Chaos Studio and might find it a useful tool in future once it goes into general availability. And again, if you want to get in touch, please feel free to reach out at any time. My contact details are on the screen. So thank you and enjoy the rest of the event.